One of the most important tools in business is Excel. Spreadsheets are an easy way to visualize and manipulate data that almost any user can operate. So it makes sense that you would benefit from outputting your data to Excel. In fact, you can even use Excel as your default reporting tool. In this video, I'm going to show you how to output data to Excel, how to format the document, and then also how to read that data back into C# from Excel. Now, if this is your first video you've watched of mine, my name is Tim Corey, and it's my goal to make learning C# easier. I provide videos twice a week here on YouTube to help you grow as a developer. I also have a full set of training courses on IAmTimCorey.com. I encourage you to check out all the resources that I have to offer. Now, in this video, as with most videos, I'm going to create some source code. If you'd like a copy of my source code, you can use the link in the description to get it. So let's get started in Visual Studio 2019. Now, in this project, I'm going to use a console application, but this is just because the console is the very cleanest user interface there is. There's not a lot of overhead and a lot of things like buttons and other stuff to worry about, layouts, that kind of stuff. The console is really clean and simple, but you can use this code in any user interface practically. The one exception will probably be the Blazor WebAssembly, which is a different animal that works all client side. So you probably have to generate your Excel file in the API portion of it and then download it to Blazor WebAssembly. But otherwise, pretty much anything will work as far as hosting this as a user interface. So let's choose the console app.NET Core. And we're going to say that this console app, let's give it a name. Just call it Excel Demo. And we'll call it Excel Demo App for our solution name and hit Create. Now, by default, this is going to create a .NET Core 3.1 application. But the very first thing I'm going to do is I'm going to get the latest and greatest version, which I'm going to right click and go to Properties and change this to .NET Core 5.0. The code will be exactly the same as far as Excel goes, but I do want to have some of the benefits of C#9 and the latest code available to me. Now, once we're in our application, we can get rid of the hello world. And now let's right click on dependencies and go to manage NuGet packages. We're going to bring in just one NuGet package today, and that is a package called EPPlus. So 2 P's. And this is not a free software if you're using it for commercial use. If you're using it for non-commercial or open source work, it's totally free. But if you're using it for commercial purposes, then there is a licensing fee. I believe it's $300 an application, something like that. But if you're using it for commercial purposes, you should be paying for it. So that's what they have required, and I definitely support their desire to eat. So let's hit install. And this is a great package. There are other packages out there that do some of the similar things. I have found this is the most comprehensive and the most polished package out here. I actually highlighted it in my 10 packages to look for in 2021. So we're going to go over how to use the basics of EPPlus. Now, right away, they open up the readme.txt, which is really helpful because it talks about their licenses, how to get a license. If you're not using it for commercial purposes, how do you work with this? In fact, this right here is what you need to do if you're going to use it for a non-commercial project. Now, this is the honor system, so that you could, in fact, use this illegally by using this and saying it's non-commercial, but use it for a commercial application. Don't do that, okay? Respect people's wishes when it comes to open source code. All right, so I'm going to copy this non-commercial license here. This is a non-commercial use. And then let's just paste that right there. And it's going to ask for control dot here, and it'll say using Office Open XML. And there we go. So now we have our license in place to use our Excel manipulation project. Next up, let's create a file location for our Excel file. So we're going to say var file equals new file info, which is going to be a system.io. Notice it's going to add that using statement. So dot, oops, not dot, open paren, and we'll give it a path. Let's give it this path. We're going to hard code this, just so you know, I'm putting the at symbol in front so I can use a single slash instead of double slash. We're going to hard code this path just because it makes it easier. A lot of the stuff I'm doing here is to show you just the Excel file manipulation. I'm doing it right in the console. I'm not doing it in a class library. I'm not using app settings for the file name and so on. This is in order to give you a very clean demo. If I were going to use this in production, I'd put this in a class library. I would probably abstract away a lot of the work and create something custom just for my application for saving and loading Excel files. But again, this is a demo. I'm going to tell you about the best practices. I'm going to mention them so that you're aware. I don't want to falsely represent how you do these things, but at the same time, I want to keep this as simple as possible in my code so you're not confused by seeing things that don't necessarily apply to your situation. Okay, so let's hard code this to C:/demos/ let's call this YouTube demo.xlsx. Okay, so that's going to be our file path for our new file. Now let's open up that location. There we go. And there's nothing in there. Okay, there's no file there right now. Just so you know, it does not exist yet. The path does, but the file itself does not. And that's important because we're going to create that file. Now we're going to start with saving to an Excel file. Since we don't have an Excel file yet, we're going to save to one. But in order to do that, we have to have data. And typically in C#, the way data is represented is with a list of objects. So let's create a class for our data. I'm going to do it right here. I'm going to say public class person model. And let's create 3 properties: an ID, a first name, and a last name. All right, very simple class that just gives us 3 properties to play around with. Now that I've created it, I like to create these classes right in line with my current class. I can see them, and maybe if I have data up here, I can mirror that or represent that well. But then when I'm done, if you control dot on the class itself, you can say move type to personModel.cs, and that creates a separate file for person model. So there you go. So it's a quick way of doing that. Makes it really convenient for creation and then also for doing it right later. So now I have my person model. What I'm going to do is I'm going to create a helper method. So let's call this static list of person model. We'll call it get setup data. All right. Now I call this static because the fact that we're inside of class program, and so static void main, in order for this to call other methods inside this same class, I have to use the word static because I'm not instantiating this class. So that's just a reference to the fact that I have to call from this method right here. I have to call this method directly instead of instantiate a new class. I could create a separate class and do all a separate class and instantiate that. I'm not going to go that far. Again, we're trying to keep it simple for the demo. So list of person model, and we'll call it output equals new. I'm using the new syntax with C#9. This is why I moved to .NET 5, which I can just say just new open close parentheses. I don't have to say new list of person model and duplicate that. Next up, I have my curly braces. I'm going to say new, and again, just say new because it knows, oh, it's a person model. And then we'll say ID equals 1, first name equals, not Japanese calendar, whoops, Tim. Wow, there's Tim. I do know my first name. Last name equals Corey. Okay, and then what we'll do is we'll put a comma at the end of that, and then copy that line a couple times. Let's just do 2 more. So 2 and 3. Sue, Storm, and Jane Smith. There we go. So, and we'll take that last comma off. We can leave it if we wanted to, but I'm going to take it off. So now you have this output list, which is a new list of person, which has 3 new person models in it with the data that you see. And we'll just return that. Cool. So now we have our setup data. This is the data we're going to store in Excel. So this represents data that might come from a database or data that you create from the front end, or however you get this data. This is what you want to output to Excel. So we're going to start with this format. Okay. So now up in our main method, we're going to say var people equals get setup data. And that will just load in that list of person model. I could have done it right in line, but this way it makes my code a little cleaner in my main method. My main method is essentially going to be the quarterback method, the method that calls every other method to do work and passes those things around. That's kind of what I'm going for here. So now let's create a method, and we're going to call it here. I'll call it first, just because it's we're going to kind of define what that method should look like. But one of the things that we're going to do in this call is we're going to save data to Excel. And that's something that should probably be done asynchronously because of the fact that it may take a little bit. If you have a large amount of data you're saving to Excel, you don't want the application to lock up and appear as though it's not functional. So what we're going to do is we're going to do an await here, which means we have to change our static void main to static async task. And control dot to add that using. And this is just fine. This is something that came in, oh goodness, maybe C#7, somewhere around there, that this came in to allow us to change our static void mains to be static async task main. So you can call asynchronous methods right inside of our main method without any kind of weird manipulation we used to have to do. So that does work. It is legal and allowed, and it's preferred to do this if you're going to call asynchronous methods. So now we can say await. Let's call this save Excel file. I know this has not been created yet. We will create it. And we'll say, let's pass in people and the file. So we're going to pass in the list of people we just created and also the file we're going to write to. And let's just do a control dot here to generate that method. So that generates this method down here, which sets everything up for us, which is kind of nice. Is, private static task, save Excel file, pass in the list of person model called people, and the file info called file. That all works for me, so I think we can leave that as such. Just get rid of the throw. Notice here that I didn't use private, but this one does use private. We can do private here. We probably should. If you don't put private, it's assumed to be private. So that just saying static is just the same as saying private static. But this way, by saying it explicitly, you're ensuring that everyone knows that it's private. Okay, so that's kind of the difference there. Okay, so in our save file, the first thing I want to do, it's going to yell at us saying, hey, you don't have a return here. No worries, we'll get there. The first thing I want to do is actually create another method. And that method, I'm going to say, let's say delete if exists and pass in the file. What it's going to do is check to see if this file exists. If it does, delete it before you run this application. This is a demo application. And so we're going to run this a lot of times possibly. And if you do, you have to make sure you delete the file every time. Otherwise, it's going to yell at you. Well, this way it deletes it for us. So let's do control dot to generate that method. And then in here, it's a really simple method. We're going to say if file.exists, then file.delete. Oops. That's a method. That's it. So if it exists, delete it. I could have done that as a one-liner here probably, but let's just create a separate method for that just to be very clear on what it does. So now for our demo purposes, this cleans things up as we get started to make sure that the system does not throw an error or exception if we already have a file there. Okay, now on to the actually working with Excel part that you've been looking forward to. Using. Now, if you don't know what a using statement is, what this is it whatever you instantiate in here. In fact, let's do the instantiation. Var, let's call it package, be explicit, equals new Excel package. And we're going to base it upon that file name. So we're instantiating this package variable. And because we're doing it inside of a using statement, what happens is as soon as we get to this last curly brace down here, this package will be disposed of properly. This package has on it, let's just show you, package.dispose, and this method called dispose. And this method is supposed to be called at the end whenever you're done to clean up the package, to make sure there's no resources that are outstanding or hanging out there. For example, we're working with an Excel file, so it's going to leave that file open while we manipulate it. Well, we want to close it so that somebody else could open it and it doesn't have a write lock on it because of the fact it's open somewhere else. So it's very important we call this dispose method, but we often forget to do that. Or you might have an exception that causes a problem that it doesn't get to this line. Well, that's where the using statement comes into play, because the using statement says anything in here that gets instantiated inside these parentheses, anything inside there needs to have implemented the iDisposable interface. And so that iDisposable has one method called dispose. So since it implements iDisposable, what's going to happen is at the end of this curly brace, it's going to call the dispose method for us automatically, no matter what. Success or failure doesn't matter. It's calling that dispose method. So that's a safety valve for us, is to have this using here. So just note that's what using for is for in this context. We have our usings up here. Those are different. These are just shortcuts. That means we don't have to type system.io before we type out file. So that's just a shortcut. Down here, this is a safety mechanism for us. So sorry, a little bit of a sidetrack there, but it's important to understand why you're doing things. And just so you know, in C# 8, I believe it is, we can now use using statements without the curly braces if we wanted to. We're not going to do that. I don't think there's a reason to, but we could do that if we wanted to. Just put a semicolon at the end here, and now get rid of that. And get rid of the curly braces and the var as well. Oops, not the var. There we go. That would be the same equivalent. And since I've already done it, I'll probably leave it like this. But what this does is it's the same as the curly braces, only it uses the end curly brace for the method to be the closure, to trigger that dispose. That can be slightly different if you have a shorter span inside your code for those curly braces. So just note that there can be a little bit of a difference in how you use this, but this allows you not to nest as deeply. So in case you had two using statements that were nested inside each other, you could just have them below each other and not have 3 or 4 or 5 layers deep of curly braces. So just note that's what that's for. Okay, we're using the using statement. So now I can say var, let's do just WS for worksheet, keep it short, equals package.workbook.worksheets.add Let's call this main report. Now, what am I doing here? Well, we've already opened the Excel package. And the Excel package is the file, the Excel file. And what is that file? Well, it's this file right here, youtubedemo.xlsx. So we've said create that file, or open it if it's already there, but create that file. And now what we're going to do is we're going to add a worksheet to that file. Now, since I deleted it first, that kind of saved us because this is just a hard code main report sheet name. If this changed all the time, it wouldn't be a problem. But if the file exists, this works just fine. It's going to open the file up as if we're going to add things to it. But you can't add an extra sheet that already is named the same thing as a sheet that's already there. Okay, so that's where you get the exception if you didn't delete that file, just so you know. So normally in Excel, if you create a new Excel document, and in fact, let's just open up Excel real quick. And in here, you'll notice that it says sheet 1 at the bottom. And if I add another one, it says sheet 2 and sheet 3. And you can put different things on different documents, like so, okay? But it just names sheet 1. Well, you can rename that if you want. So I could say test, and now it's the test sheet. All right, well, that's what we're doing in our, don't say that. That's what we're doing in right here. We're saying, hey, go ahead and add a sheet called main report. So this is gonna be a little bit nicer than even the default for Excel, where the default is sheet 1. Well, we're gonna say main report instead. So now we have a new sheet in our new Excel file called main report. And now what I'm gonna do is we're gonna add some data to it. So since I have this list of people, I am going to say var range, which represents a range of cells. I'll say range of cells equals worksheet.cells. I'm going to start at A1. Oops, in quotes. A1. That's the start of our range. I'm going to say load from collection. And this allows us to pass in IAnnumerable of t, which we have. That's our people. And if you're wondering, well, you said, well, Tim, actually it's a list of t. Yes, because IAnnumerable is an interface and list implements the IAnnumerable interface. So we can use that interchangeably there. So we have passed in our people list. And the last thing I want to do is say true for print headers. This is where those nice little tags help me out here that show me even after I say true. It says, oh, print headers is true, which what it's going to do is take our data from our list of people and it's going to save it into Excel as columns and rows. And the first row is going to be the header row where it takes the property names and it puts them in as the in the first column. So that's pretty much it, okay? So now I'm going to say range.autofit columns. So if we, in Excel, sometimes you can have a column that's too narrow for your content and it kind of, it doesn't show everything. And you can double click on the columns separator bar and expands it out to fit the column. Well, that's kind of what we're doing here. We're saying, hey, fit all this in so that it looks right and we're not having hidden content on our Excel file. And finally, we say await package.save async. There we go. Save async. We have one issue left to take care of. It doesn't put async in our method signature when we create that or generate that. And I often miss that because it does have task. But the reason why is because we don't always have to do await in this method. We could say not to await this and have no await. and instead have it return that back to here to be weighted. But in this case, we're just going to await it right here. That's fine. So that's it. We have created the Excel file. We have created a new worksheet. We have said starting at cell A1, which is the upper left-hand corner cell, load from collection that people, which has, remember, 3 people in it, Tim, Sue, and Jane. We're going to load this list into our file. So that's going to go into our file, and we're going to print the headers as well. We're going to auto-fit those columns so we can make sure those column widths are the right widths and the heights of the rows are the right heights. And then we're going to save asynchronously that Excel file. That's it. We're done. That's all it took to write a list of people out to Excel. Okay. Now, don't leave the video yet because we're going to do a lot more than this, but I want to show you just how simple it is to write to Excel. So let's pull up that folder. We'll wait for it. And as soon as this runs, boop, it's done. So it just exited. That's all it was. Let's open this up. There we go. I can zoom in a little bit for you. We have our ID, first name and last name, 1, 2, and 3, Tim, Sue, Jane, and so on. And notice the sheet down here says main report. So that's all it took to write to Excel. Really straightforward for collections, which is the most traditional way of storing data in C# anyway. So you already have our data in a collection. Therefore, to write it to Excel, really simple to do. Boom, there you go. But that right there is quite plain. So if I were doing this, I would probably do something like this, where I'd bold these. I'd probably center this column. In fact, I'd probably center both of these columns for the headers, but leave the bodies left aligned. But I'd center this one because it's a number. I'd probably make maybe one of these a little bigger because, last names might be a little bit larger sometimes, and so on. I'd probably play around with this and make it a little nicer, right? Well, we can do all of that in C#. So let's do this. Don't save. And in fact, we're going to delete this. We're going to start over. So I know I delete if exists, but I want to show you that yes, we are in fact not, there's no trickery here. I'm doing it all through code. So let's come down here after we auto fit our columns, and we're going to do some manipulation. And in fact, I'm going to change this right here to say, instead of A1, let's say A2, which means that the header row will start on the second row, not the first row. Because I want to play around with that first row and have kind of like a report header type feel. So down here, I'm going to say worksheet dot cells, and let's address cell A1, which is no longer the header row. That's A2. So dot value equals our cool report. So this is kind of like the overall title of our report. And then we have our column headers after that. So, but the problem is that goes into A1, and that would be a problem because it's only going to be over the ID column, not over first name and last name. So let's do this. Let's say WS cells, and let's say that we want A1 colon C1. So A1 through C1, which is the 3 columns we have for our ID, first name and last name. We're going to say merge. And we'll say true. That's going to merge all 3 of those together so that A1 now spans those 3 columns. But we're not quite done yet. I want to say worksheet.cells, and I'll do the same thing here. Let's do, actually not even cell, let's do columns. Let's do column and say that column 1, it's base 1 here. So column 1 dot style dot horizontal alignment equals center. Okay, now let's open Office XML.style. We can get rid of that and do control dot. This is a enum, so you can find your list here like center continuous, distributed, fill, left, justify, right, and so on. I'm going to center column 1, which just happens to be what our cool report is, but also happens to be what the ID column is. Now I could have said, hey, just center certain cells, but I'm going to do the whole column because it's convenient for what I want to do. Now let's also make that first row. So WS row and row 1, which is that our cool report row. Let's change the style.font.size to be 24. It's a really big, bold title, right? And then also on row 1, so ws.row1, we're going to say that the style is going to be, the style.font, we're going to have a color for that and say set color, not set auto, set color. Set the color, and let's choose a color here. So again, we have, let's not set one of those colors. Let's just do a color dot, capital C, dot blue. And this uses the system colors here, so we can use system.drawing. So now you set the font for our cool report to be blue. Is this going to be hideous? Yeah, probably. But I just want to show you all the different ways of manipulating, where you can manipulate one cell, you can manipulate a section of cells, a column, or a whole row. So I think that that's probably good for that first header. But let's put a code comment here. Formats the header row. Just the header. And then down here, let's say that we want to manipulate a couple more things, other miscellaneous things. For example, ws.row2, let's set the style horizontal alignment equal to, have the equals first, center as well. So row 2, which is that header row for our columns, the ID, first name, last name, we're going to center the whole row. And then along with that, I'm going to say that row 2, style font bold equals true. Just set that as a bold style. I think that's probably good. And then let's say that ws.column, let's do column 3, which is that last name column. And we'll say that the width of it should be, let's go to 20. Just to show you can change the width of a column after you've auto fit them. So if you do this first and then auto fit, that'll overwrite this. But if I do auto fit first and then say, I actually want to override that to something else, you can do so. So that way you could auto fit the whole document and then manipulate one column that maybe is just too large normally. So let's again check our demos folder. There's nothing in there. Let's run this and go back to our demos folder. And there's our new file. And we open this up. And there's our cool report. So we have, let's zoom in a little bit here so you can see it. We have our really big title here. Notice it's centered in these 3 blocks, even though these 3 blocks are different. We've got our different font size and different font color. We have our bolded row 2, which is our header row for our columns. We have this column right here that's been centered. So, and this column right here is a different width than it would be normally if we had auto fit it like so. All right. So it was 20, something like that or so, I'm not positive, but somewhere around there. So that's how you format your document. And we can add multiple tabs down here just by manipulating this, where you say add worksheet. So I've been using WS for worksheet, but it's always been main report. Well, I could change this to create another worksheet and do more work and have more data on this Excel file if we wanted to. That's pretty common for when you want to do things like you have your first tab be the summary data, and then you have other tabs with the data that supports the summary data, maybe the full data to back up that summary data, and so on. So there's a lot of stuff you can do with, especially reporting, but in general, manipulating your Excel file. You can put borders around things, you can put formulas in. Basically, you can do whatever you want to do with Excel. Now, I do want to share one thing here. Let's go to close this and say don't save. And let's open back up our demos. And notice here we have a 3 kilobyte file. I'm going to copy this. I'm going to paste it. Okay, so there's our copy. I'm going to open up the copy, and I'm going to just close it right down. And it says, do you want to save this? And this is it's not a bug, but it's something to be aware of. So I would say hit yes, because I haven't changed anything, but sure. And if we look that now, let's see if we can zoom in here. The copy is 10 kilobytes versus 3 kilobytes for our YouTube demo. So why is there a difference there, and why does it prompt us for saving it? Because if we open up this copy again and just close it right down, it doesn't prompt us to save. And the reason why is because of what's actually happening behind the scenes. So when EPPlus creates our Excel file for us, they're not actually creating an Excel file. They are creating the data necessary for the file, but it's not the same thing as actually using Excel. There's metadata and other things around that get created when you actually use Excel. But the benefit of using EPPlus is we don't have to have Excel installed on the server. Now, if you did, you could create a little script to open up these files, save them, and close them, and that would finish off the process of creation of a document. But this is a very standard thing that happens whenever you generate an open Excel or open XML file as an Excel file without actually using Excel. This is common to pretty much everything that uses open XML. So this is not a bug. This is not a missing feature. It's just something that you have to understand about the files, because technically these are zip files. So if we were to put the .zip extension here and then open them up, you'll see documents and other things, XML documents in here for our file. And if you were to compare that with our copy, you'll find in here, in the copy, there's some differences as far as our properties and other things that are in here. So you can do a comparison here. It's all metadata essentially that's been changed, but just note that that's the difference is when you actually open Excel, it creates the rest of this metadata stuff. So that's where the differences in file structure are. So the first time you open that file, you're going to see that save dialog. You can say no, and it actually keeps the size smaller. But if you say yes, it will change the file, but not with any data. It doesn't change any data. It just changes some metadata. So just be clear about that from the get-go. And that's not an EPPlus thing versus something else. Okay, that's a standard thing. Okay, so you've seen how to write to an Excel file, but that's really only half the battle. Let's figure out how to read from an Excel file. So to do that, let's say list of person model. Let's call this people from Excel equals await load Excel file, passing in the file. Again, we haven't created this yet, so let's control dot to generate that method. And let's make sure this is async task and get rid of our throw exception. So this is going to load in a list of person model from our Excel file. So how do we do that? Unfortunately, it's not the easy process that it is to save to Excel. And the reason why is because inside of our objects, we know the types and we know how to then put them into Excel. But getting them out of Excel, we have to figure out which columns go where and what range are you talking about? And are you done at the end? How do you know where the end of the file is? And all these questions that we have to figure out. So we're going to do this. I'm going to show you an example of how you would do this. It would be a not manual process, but a custom process per file type. You couldn't just throw random files in here without some work with generics. And there is some really cool stuff you can do with generics. I have done some work like this where you kind of throw any file you want at it and it loads it into strongly typed objects, but it does take a lot more work to plan out and do right. And even so, you got to think through things like our header row, which we have to account for. Where it says our cool file or whatever it says, that wouldn't be part of our data. So we have to make sure we don't include that when we're looking at importing data from Excel. So just note there's some things to think through, but this can be a really beneficial process. I want to make sure you know how to do it. First, let's create a list of person model, and this we'll call as output equals new. And this is going to be the file that we create to output our list of person model from this method. Okay. One thing to note too, if you did not upgrade to .NET 5, you can't do this. So you have to say new person model. That's pretty much the only change I think that you'll see come from my code to your code if you're not using .NET 5. All right. So and don't forget you can download the source code. There's a link in the description so you can compare mine to yours if yours doesn't work. And that's probably one of the first things to check is to make sure that you've set yours to .NET 5. All right. So using var package equals new Excel package, and we'll pass in that file. Again, we're using the inline using statement instead of the curly brace model. And we'll say await package.load async. So it's going to load the file asynchronously. The file does have to be there. So make sure the file is there because I'm assuming the file is there. I would, in a production application, do some checks here to make sure the file exists and that it is in fact an Excel file. But load async will load this file, assuming it's there. Now, var ws for worksheet equals package.workbook worksheets. And instead of using a name, I'm going to say the first worksheet. All right. And you can go through and figure out if worksheets exist and so on. But I'm going to say just give me the first worksheet. We're going to work off of that one. So now I'm going to create two helper variables, int row equals 3 and int col equals 1. And this is going to help me with my rows and columns. I'm saying row equals 3 because let's look at our Excel file here. Let's open it back up. I deleted it. No worries. Let's go to our save Excel file right here. So row 1 says our cool report. Don't want that. Row 2, which is this one right here, is our headers. So I don't want that one either. I want to start with my data. So that would be row 3 is where we start. So while string.is null or white space ws.cells row call dot value question mark dot to string, and we're going to say equals false. Oops, I'm missing a paren in here. All right, so what is all of this? So I'm looking up the cell at row 3, column 1 to start with, and saying, is row 3, column 1, is the value, first of all, not null? Because this question mark right here says if it's null, then throw this whole thing out because we're done. We can't evaluate this to be a string or not. So if it's not null, then do a toString on it, the value of it. And if that value is not null or white space. So it's looking at the Excel file and saying, okay, is there data in this column, in this row, in this specific cell? And the reason why I'm doing this is because I'm saying I don't know when the last row in the file is. And this is how I'm determining it. If there's no data in that first column for a given row, I'm saying that we're done. There's no more data in the file, because my assumption is with the ID column, there will always be an ID number for record. There might not be a first name, there might not be a last name, but there will always be an ID number. So that's how I'm determining when that last row is, when I don't have any information in that row. So this while loop's going to keep going until it's null or white space in that cell. Okay? So we've determined that whatever row we're on, there's data in there. So therefore, we're going to say person model P equals new. I really like that new syntax. It keeps things shorter. P.id equals int.parse. WS cells at row call, say dot value dot toString. And why am I doing toString here? Well, because this is actually an object, and if you don't say toString, what's going to happen is it's going to pass whatever type it thinks it is, which is a double. So numbers get treated as doubles by default with Excel. That's a problem for int, because if I try and cast it to an int, it's going to say you can't do that. You can't cast a double to an int. So this is a shortcut way of doing it, which is to say, hey, take that value, output a string. Whatever it is, don't care. Just give me a string representation of that particular cell. And then I can say int.parse, because I'm going to know that it really should be an int. Therefore, that should parse just fine. Now, I could do a try parse in here and do some more safety checks around this, just in case Excel threw a .0 at the end or something like that. But I think this will work just fine for our demo purposes at least. And in the real world, yeah, you could do some more checks around this just to be very sure that you know the value is correct. Now, for the next values, things get easier. WS cells row call plus 1. Okay, so that would be the second column, and dot value to string, because oops, that's not minus, that's an equals, because toString represents the string value, and we're storing it as string, and it is a string, therefore life is good. Copy that line once more for last name and change that to +2. So now column +2, so that'd be column 3. So 1 + 2 is 3, and that gives us our last name column. And now we can say output dot add P, and don't forget to say row plus equals 1 to increase that row number to the next row in line, which is then going to do a check for the while loop. If you miss that line, you will have an infinite loop where you look at the very first row over and over and over and over and over again. Don't do that. All right, after our while loop, we can just return output. And that gives us our list of person model from our Excel file. So we can come back up to the top here. And let's just say, we can take this person model and say for each. And we'll say var p in people from Excel. And we'll do a console write line with a string interpolation. And say, just really simple, p.id space p.firstname space p.lastname, and then save that. That's going to output the people from our Excel file. So we have now, we're saving to the Excel file, and then we're also reading from that Excel file afterwards and loading to a different list. Just note, we're not pulling from that same demo list, so that we're not cheating here. This is a brand new list that we're loading up. Let's run this, and I'm going to drag us over here, and notice it says Tim Corey, Sue Storm, and Jane Smith. It loaded all three of those from the file. So it knows there were 3 records, and here are those 3 records. They're now strongly typed inside of C# from Excel. Just to show you that the power of this, let's take away the save Excel file. So we're not going to save it anymore. We're just going to work off of this file and read from it. And let's open this file up. And let's add some more IDs here. Bill Smith. And let's say Mary White. Okay, so two new records. They're not in C#, but when I go to run this, Bill Smith and Mary White. So it brought in those additional people because they were in the file. How is that significant? Well, because you can give this Excel file to someone and say, fill out this information, and then they have it automatically loaded into your C# application and processed. Maybe put into a database, maybe have work done on it, whatever you want to do. But this is now a potential user interface, Excel is, for your users. You can give them an Excel file and say, fill this out, and they know how to do it. They can work with it, no problem. They'll fill it out, and then you can run it through your C# application, import the data, work with it, manipulate it, and so on. Or if you have data that's been exported from another system into Excel, you can then take that data and use C# to bring it into your main system or a different system to work with it. So a lot of cool stuff you can do here with both saving and loading data with Excel. Now there is a lot more that you can do with Excel. You can do things like graphs, you can bring in images, you can do charting. All this really cool stuff you can do with Excel, you can do with EPPlus, Spark lines, and so on. So there's a lot more to cover, but I think those are the main things that you will really need Excel for, is that, especially that saving to Excel file. That right there, with just a few lines of code, you can output your model to Excel and call that your report. So many of you have asked me for free reporting solutions, and there's not great options out there. There's not great systems where you can say, yeah, there's a free reporting solution for C#. But this is, while not necessarily always free, not free for commercial, but free for non-commercial and I believe for open source projects, it's a great option for outputting data. And even if you are commercial and have to pay a little bit, the nice thing is you don't have to pay anything until you're actually going to use it in production. So you can create your demos, you can show this off to your boss, you can build even your sample application to show off what it could do for free and show it all off to your boss and say, hey, it's going to cost $300, I believe is what it costs, but this is what you get out of it. And that can be a really easy value sell. You say, here is a value that you're going to get day one. And so that's a kind of an easier way to do reporting inside of C# that might not cost as much as some of these more expensive and more complicated and time-consuming reporting solutions. Plus, your users will almost always know how to use Excel, or at least open Excel files up and do the basics with it. And this can make their lives easier. Okay, so that's it for working with Excel. If you have any questions or any thoughts, leave them down in the comments. I may do another video with another Excel library in the future. We'll see. But I want to show this one off because I think this is the most well-rounded solution out there on the web today. So thanks for watching. And as always, I am Tim Corey.